today we'll discuss multilinear regression. So we have already discussed a two-variable linear model in my earlier videos, and so it is the reference, and the linear algebra. Linear algebra is the basic for this we'll discuss. Now let us assume that y is the function of k number of independent variables. Y is a dependent variable and x1, x2, so on up to xk are independent variables. So it is explained by these independent variables on this. Now u is a disturbance term of and number of observations are n. So the model will be yi is equal to beta 1, this is the intercept, beta 2 x2i plus so on beta k xki plus ui. I ranges from 1 to n number of observations. So we'll have to obtain the estimates. Say what will be the beta 1, beta 2, so on up to beta k. So in matrix notation, in short, it is y is equal to x beta plus u. So y is equal to y1, y2, so on up to yn, n number of observations on dependent variable, and x is a matrix where it is 1, 1, so on up to 1, and this is good for obtaining this beta 1 intercept. So when we have to find out the beta 1 intercept at the same time, so it is 1, 1, so on up to 1. So x2, 1. So suffix 2 stands for two stands for the variable, second variable, first row, and kth variable, first row. Okay, x22, second row, second variable, and so on. So there will be n number of observations for k number of independent variables. Okay, so this is okay. Now intercept beta 1 requires the insertion of a column unit in the X matrix. X has a rank k less than n. So as I said earlier, why 1, 1, 1 is considered. So we have to insert column units in the X matrix. Okay. Now XIS and I stands for rows and J stands for columns. And crucial assumptions, we have already got it earlier. What are the crucial assumptions? Expected U is equal to 0 and expected U prime is equal to sigma square IN. This is variance covariance matrix. It is a mean expected U, that means the error term, expectation of error term should be 0. There should not be any values to be best estimates. So expected U is equal to 0 and expected U prime is equal to sigma square I, variance in the identity matrix. UIs are variables with 0 expectations. Okay, so it is written here. And U is an n into 1 column vector, and U prime, which is a transpose, is a row vector. If U is a column vector, U prime is a row vector. Then U prime is a symmetric matrix or symmetric matrix of order n. Okay, so this is some order n. So expected u prime, how you can develop this matrix, expected u prime, expected u1 square, expected u1 u2. So here is the first row, first column, and first row second, that means expected u1 u2 so on up to expected u1 first row and un, or n number of observations. Then expected u2 u1 so on u2 square, so expected u2 un. Then expected un u1 is expected un u2, so expected un square. So this can be written as sigma square 0 0. So the diagonal elements will be sigma square, and off diagonal elements will be 0. So that means sigma square is a variance and off diagonal elements are covariances. Covariances are 0 and variances are sigma square. And expected ui square is equal to sigma square. Expected ui uj is equal to 0. And ui's are uncorrelated. So this is equal to, if we take out sigma square as common, sigma square is equal to 1 1 1 and 0 0. That's why we write sigma square in. Sigma square into identity matrix. Okay. So the diagonal elements expected ui square is equal to sigma square in. That means this is the constant variance and this is the identity matrix. So expected ui uj is equal to 0. This means the covariances of the error term is homoscedastic. This means if the covariances are 0, it is called homoscedastic. If it is not 0, it is called heteroscedastic. So and two variables are not multiple to each other. That means suppose the values of x1 and values of x2. Now if x2 values are say multiple of this, each value is a multiple of this, then it will not work because the determinant will be 0 and inversion will not be possible. So least square estimation, that we have to estimate the parameters, estimated beta is equal to beta 1, beta 2, so on. So it is a column vector, but we can use second bracket to use as a row vector. So when you use the second bracket, it is a column vector. So we discuss in the matrix. So it is a column vector. Then y is equal to x beta hat plus e. So we can write like this model. And e, what is e? This error y minus x beta hat. So observed value minus estimated value. So this is the error. So as we discuss in two variable linear model, that the line should go through the points, but if it can divide the scatter into two equal halves, then also the error will be less. So this is the error from the point to the line, average line, and this is the column of residuals. Now, summation EI square, if we need the square and sum of, it is also represented as E prime E is equal to Y minus X beta, E prime mean Y minus X beta prime is transpose of this, and E means Y minus X beta. So if we remove the bracket, so this is Y prime Y minus 2 beta hat prime X prime Y plus beta hat prime X prime X beta hat. Now you see this beta hat prime X prime Y is a scalar quantity. So it is a single figure. So that's why transposition of this is equal to the origin one. No? So equal to its transpose. Transpose of this is Y prime X beta hat. Okay. So to minimize this, now we'll have to minimize the error. Okay. So to minimize the sum of the square of the error, we'll have to differentiate, because we'll have to minimize this error, or the error, the sum of the square of the error term should be the least. That's why we call it least square method. So summation EI square is equal to this, and delta by delta beta hat E prime E is equal to minus, if we differentiate with respect to beta, it is minus 2x prime y plus 2x prime x beta hat. So this should be equal to 0, because in maxima and minima, to minimize a function or to maximize a function, first derivative should be equal to 0, and second derivative, if we derive this again, so it will be positive. Second derivative should be positive to minimize. So second derivative will be positive. So simplifying, if we simplify, putting this is equal to 0, x prime x beta hat is equal to x prime y. So what is beta hat? X prime x inverse into x prime y. So beta hat, this means beta hat is equal to x prime y divided by x prime x. So this you can write beta hat is equal to x prime x inverse x prime y. So thank you very much for watching. Keep on watching, and please subscribe and share. Thank you.